All right, so on this second one, we've got 2 carbons and 6 hydrogens. So when we look how to set this one up, again, we want whatever comes first in the formula to be in the middle. So if there's more than 1 carbon, you just put them side by side. Just like that. So if this was, let's say it was carbon 5, hydrogen 13, you would just keep adding carbons and make that big chain. Okay, if there was 5 carbons, if there were 7 carbons, right, you would just keep them all going like this, and then you would put your hydrogens around them. Okay, so those all just join together in the middle. But we only need 2, so let's take the rest away here. All right, so each carbon wants how many bonds if we look at our rule? 4, right? 4. So we know there's 1 for each one of them, 2, 3, and 4. Okay, so now we know that our carbon has our 4 bonds that they need. Hydrogen only wants 1 bond. Right, and we have 6 of those to fill in. So if we put 1, 2, 3, 4, 5, and 6. Okay, that works out really well so far. So now let's add up our valence electrons. Okay, so again, we can put that in our last column here on our sheet. Carbon, there's 2 of those. Each carbon has 4 valence electrons because it's in group 14 again. We've got 6 hydrogens. So instead of writing 6 hydrogens, I'm just going to put a 6 in front of it, knowing that we multiply our hydrogen times 6. So each hydrogen has 1, so that would give us a total of 6. So if we add that up, we get 14 valence electrons. So we have to make sure there's 14 electrons in our picture here. So 2, 4, 6, 8, 10, 12, 14. Okay. So we're good with this rule. We're good with this rule. Now we just have to circle everything and make sure everything has 8 or 2 valence electrons. So hydrogen just needs the 2 again. So as long as there's a bond there, we know all our hydrogens are good to go. If we look at our carbon, as long as there's 4 bonds around each carbon, right, we're good to go there. These get a little crazy with all these circles, but so we've got all 3 of our rules. The Hunk rule is satisfied. We've got the right number of valence electrons, and everything has a full show. Questions on either one of those so far? Now I want to flip to the back and do some of the ones that are a little crazy. So let's look at ethyl alcohol, the CH3OH. So when you get a longer formula like this, where you have lots of different elements, you want to read your formula from left to right. So you'll write your carbon on first. Whatever comes after that carbon has to bond to your carbon. Okay, so we know that these 3 hydrogen right here have to bond to the carbon. So we put our carbon down, we attach the next 3 things to the carbon. Then we come to the oxygen. So the only place the oxygen can combine is with the carbon here. Okay, so it wants to bond to that carbon. And then we know that hydrogen has to bond to this oxygen. So you kind of just read it as you go. You add everything in. Some of them are a little bit crazy, but if you follow that pattern, it usually works pretty well. So let's look at our Hunk rule again. Does each hydrogen have 1 bond? Well, of course, right? Or they wouldn't be there, so that's good to go. Does our oxygen have 2 bonds? It does. 1, 2. So that's good. No nitrogen. Our carbon has 4 bonds. Okay, so Hunk rule is good to go. Now we have to add up our valence electrons. So carbon again has 4. There's a total of 4 hydrogens. Okay, so hydrogen, I'm just going to put times 4 here. That would give us 4 more. And then oxygen has 6. So that gives us 14. So if we count, we've got 2, 4, 6, 8, 10. We've only got 10 electrons there. So we don't have enough electrons yet. So what I usually do is I start drawing my circles to see where I'm missing something. So again, usually start with hydrogen because as long as there's a bond there, those are all set to go. And then carbon has the 4 bonds, so we know carbon is good to go. So what we're missing then has to be with our oxygen here. and we only have 2 bonds, so we only have 4 electrons with our oxygen, and we need 8. So what do we have to do inside that circle to fix that? What do we have to add? Do you remember how we did that? It's been a long time. We just have to show.
Like add 2 bonds.
Not bonds, but we drew them as, do you remember how we drew them? Instead of as bonds like this, we drew them a different way. We drew the electrons a different way. It's been a long time. Do you guys remember? We did them as dots. Like that. Do you guys remember doing that? And we paired them up. Okay. So we have 2 pairs of dots that we need to add into that. Okay. So now we have 8 electrons around our oxygen. Now, if you notice, I did both pairs up here on the what I would call the top of the oxygen. And notice how this angles downward. That has to angle downward because these are negative charges that are repelling and pushing away from each other. Because 2 negative things don't want to be by each other. They want to push away. Okay. So we're going to look at a couple more examples like that. Okay. So I redrew it here for this example. Okay. So if your oxygen is on your carbon and then you've got the hydrogen, free electrons always go at the top and that bends down. Okay. Another example, water. And we talked about this last chapter. Okay. We can't draw water like this because that's not polar. It's incorrect. We have to draw the free electrons at the top. They push away from each other and they cause these electrons then to push away and angle downward. So when you draw water, it must be drawn this way or it'll be incorrect. Okay. Another one you'll see a lot is this one, ammonia. We've got our nitrogen with our 3 bonds, and then almost always you're going to have a pair of free electrons on top of your nitrogen. These push away from each other and they cause those bonds to go downward. So do not draw it like the top one there. Don't draw them straight out. They angle downward because of that repulsion. So make sure you remember to do that. And then I think that was all the examples that had the free electrons. I'm going to show you one more thing and then I'm just going to give you time for it. Mathematically, you can figure out fairly simply how many bonds that you need to draw in your structure. So I'm going to show you how to do that quick. And then if you guys want to practice with that a little bit more, I can show you a couple more, and I also have all the work on the practice paper so you can look at it and see. So what we do is we add up our valence electrons just like we've been doing. So we know carbon has 4, each oxygen has 6, so that would give us 14. Right, so that's the important one right there, 14. When we're done, we have to have 14 in our structure. If we want to figure out how many bonds, we then figure out how many electrons are needed for a full shell for each one of our atoms. So every atom, except for hydrogen, always wants how many electrons for a full shell?
Would that be 16?
Did I add wrong? Yes, it is 16. I'm sorry. Thank you. As soon as you said that, I'm like, yep, it should be 16. So every atom wants how many electrons for a full shell? 8, right? 8. So since there's 3 atoms here, 3 times 8 is going to be 24. So if we know how many valence electrons there actually are, make sure you add right, unlike me, okay? Then how many we would need if they all had full shells. We're going to subtract those 2 numbers. So 24 minus 16 will be equal to 8. This tells us how many electrons are in the bonds. Okay, just by subtracting those 2 numbers. We know that every bond has 2 electrons. So if we know how many electrons are in the bonds, if we just divide that by 2, then we know there's going to be 4 bonds in this structure. Okay, so this is just an easy way to figure out how many bonds, so you're not drawing all your dots and then you have to erase them and move them over. You do not have to do it this way, okay, but it's a way that makes it a little bit quicker as you get more proficient doing this. So I will leave this up on the board for you guys to look at if you want to. All right, so then if we draw our structure, carbon's going to be in the middle. We've got our oxygens. Okay. Since we figured this out, we know there's going to be 4 bonds. So if I draw like this, I know that is not enough bonds. I know that I'm going to have 2 bonds on each side or a double bond on each side for this structure to be correct. So it saves me a couple steps. Instead of drawing all my dots, my 16 dots in there and then moving them all around, I just automatically know there's going to be 4 bonds. That gives my carbon 4 bonds, following the Hunk rule, and it gives it a full shell. It gives each one of my oxygen 2 bonds like they want, so that Hunk rule is good for them. But if you do your circles, there's not enough electrons there. So we have to add our extra electrons as our dots. And we have to do the same thing on each side so that there are enough electrons for each oxygen. Then we go back to our number 16. And do we have 16 electrons here? Well, we have 2, 4, 6, 8, 10, 12, 14, 16. So we're good to go. Hunk rule is good. Total number of electrons is good. Everything has a full shell. So that's a good structure. So I'll leave that up there if you guys want to do that math. And if you want to do a couple more examples, we can also do that together. So the rest of the time is for you guys to practice. With about 20 minutes left in class, we're going to move to the online activity and look at a little bit of the polarity, because that's what we're going to talk about tomorrow. Okay, so you have a ton of time to work on.